In this video, we're going to take a look at some beginner level Angular interview questions. All these questions come from the documentation, but you might be interested to know that I've personally asked or heard others ask candidates each question in this list. Let's go. Angular is a free and open source application design framework written entirely in TypeScript. It's useful for creating efficient and sophisticated single-page applications, or SPAs. It was written by and is mainly supported by Google's Angular team, along with a community of professionals and corporations. It's used in many popular websites today, including Gmail and YouTube. TypeScript is a free and open source, high-level, strongly typed programming language. It is a superset of JavaScript and is also transpiled to JavaScript. It was built by Microsoft specifically for the development of large web applications. Angular supports two-way data binding. That means that if you create a property inside of a component and then assign that property to the property of an HTML element, if you update the property in the component, it will also be updated in the HTML element, and vice versa. You see the variable customer name, and it has an initial value of ABC Corporation. In the template, the customer name variable is being used in 3 different locations in 3 different ways. First, the value is just being printed out with the double curly braces. Using those double curly braces is also called Angular interpolation. Second, there's a text box with a two-way binding with the customer name value set to the ng-model attribute. This will bind the customer name variable in the component to the text value of the text box. The square bracket surrounding the parentheses is how to wire up two-way binding. So again, if the value of the text box is updated, the property in the component will also be updated. And if the value of the property in the component changes, the HTML element will be updated. And last, that same customer name property is bound to the value attribute of this second text box. This is a one-way binding, and if the value in the component changes, it will update the HTML element, but a change in the HTML element will not change in the component because it's just a one-way binding. So we can see ABC Corporation in all 3 locations. If I change it in the first text box, all 3 locations are updated at the same time. However, if I update that value in the second text box, nothing changes except that text box. The model isn't updated because of the one-way binding. And if I again change the value in the first text box like this, it updates the second text box. That binding on the value is still there, even though I changed the value of the second text box once already. Single-page applications, or SPAs as they're commonly known, are web pages that act more like traditional desktop apps. The needed parts of the application, including the HTML, the CSS, and the JavaScript, are all downloaded when the web page initially loads. Then, instead of new pages being loaded, that same page is rewritten with content and data that either comes fresh from the server or that was previously downloaded in that initial page load. There's actually quite a few differences between Angular and AngularJS. Angular was written in TypeScript, AngularJS was written in JavaScript. Angular is component-based, while AngularJS uses Model View Controller, or MVC, and Model View ViewModel, or MVVM. Angular has support for mobile browsers, AngularJS does not. And personally, I found Angular to be a lot harder to learn than AngularJS, even though when I learned Angular, I already knew AngularJS. Angular does come with some pretty good tooling in the form of the CLI that helps you get up to speed pretty quickly if you just use it. And AngularJS doesn't have any tooling at all. And Angular, it's just faster than AngularJS, hands down. Decorators are special TypeScript annotations, and they provide metadata about a class, property, or function. They enhance, or at least they change, the behavior of the elements that they're assigned to without changing the source of that element. There are 4 types of decorators in Angular. First is class, and those include the component, ng module, pipe, and injectable decorators. Then there's the property decorators like input, output, and viewChild. There are parameter decorators like inject and optional, and then there are method decorators like host listener and host binding. Most of these are touched on in this video. Templates are HTML snippets or files that tells Angular how a component should be rendered. It's specified in the component decorator, and you have 2 options. You can use either an external file using the template URL property, but you can also do it inline with the template property, and that template is wrapped with backticks containing the markup for the template like this. Directives are classes that add additional behavior to elements inside of an Angular application. There's 3 different types of directives. First, there's components. They're made up of the TypeScript component class, the CSS selector, the template designation, and optional CSS. There are several examples of components throughout this video. Second, there are attribute directives, and these listen to and modify the behavior of other HTML elements, attributes, properties, and components. There's several attribute directives that comes with Angular, including ng-class, ng-style, and ng-model. And third are structural directives. These are responsible for the HTML layout. They shape and reshape the DOM by manipulating or adding and removing HTML elements. Angular also has a couple of these out of the box: ng-if, ng-for, and ng-switch. You're going to be very familiar with these. They're everywhere. AOT is an acronym for ahead of time. The Angular AOT compiler takes your Angular HTML and TypeScript code and converts it into efficient JavaScript code during the build process before the browser downloads and runs that JavaScript code. Components are the basic building blocks of all Angular applications. They consist of the component decorator, the CSS selector, the template or template URL property, the optional styles, and the TypeScript component class. Here's your friendly reminder to like and subscribe. We publish new videos every other Sunday for software engineers, software developers, and software architects. Thanks. Angular pipes are simple functions that you can use in template expressions that accept an input value and return a transformed or formatted value. They're reusable, and if you find yourself having to specifically format a value, you should consider using a pipe. Angular comes with many, but these are the most likely pipes that you'll see. Date pipe for formatting a date to the current locale rules. Uppercase pipe to transform a string into uppercase. The lowercase pipe to transform a string into lowercase. The currency pipe, which will transform a number into a currency string for locale rules. The decimal pipe, which will transform a number into a string with a decimal point, also formatted to locale rules. The percent pipe, which will transform a number into a percentage string per locale rules. Those are the most common, but there are others. There's a couple of pipes that help with I18N internationalization problems. There's the key value pipe, the slice pipe, the title case pipe, and the JSON pipe. Before getting into ng modules, I just want to note that the Angular team seems to be encouraging developers to move away from ng modules, but there's a lot of applications out there that use them, and most likely you'll see them in code and encounter them in interviews, so it's still an important question. Here's the message from the docs. Older Angular applications are built with ng modules. While this is no longer the preferred approach, many existing applications are still built with ng modules, yada yada yada. You can think of ng modules as containers for related functionality. They break out our applications into smaller and more manageable chunks. For example, a CRM application might have modules for customer management, contact management, and sales. They're also very popular in third-party libraries like ng Bootstrap or PrimeNG. In those libraries, typically there are different modules available for each control. That's good for us. It allows us to pull in and use only what we need. And I think the same should go for the modules that we write. Using modules is also a great way to allow lazy loading in our applications with a minimal amount of work. The modules are there on the server, but they're only downloaded when they're needed. This makes our bundle sizes smaller, and it makes the initial page load a lot faster. I think this question's a bit of a trap. In AngularJS, managing scope was a pretty major issue. It mostly worked, but it also caused problems. But in Angular, scope is mostly locked at the component level, and we can pass data from a parent component to a child component using the input decorator, and from a child to a parent using the output decorator. Or you can just use services. When we talk about lifecycle, what we're actually talking about is component lifecycle. The structure of your component determines which of these events will fire first. If you have data binding inside of your component, ng on changes will fire first, and if you don't, ng on init will fire first. But let's start with ng on changes. Try not to do any work here. You can tie into this event, but you shouldn't. Find another way. If you screw up here, then your application performance is going to be really bad. This event fires every time a data-bound value changes. ng on init initializes the component, and if there are no bound values, this fires first. Next, ng do check. This is responsible for custom change detection. So in cases where Angular can't or won't find changes, this will fire. It's called immediately after ng on init and every subsequent change detection run. ng after content init runs after Angular projects external content into a component or into a view that the component is in. It's only called once after the very first ng do check finishes running. ng after content checked is next. It runs once after ng after content init and after each ng do check run. ng after view init runs once after ng after content checked runs. ng after view checked runs after Angular checks the component's views and child views that contains the component. It's called once after ng after view init runs and after every ng after content checked runs. And finally, we have ng on destroy. It's called immediately before Angular destroys the directive or component. And listen up, kids. This is important. This is where you unsubscribe to your observables and detach any event handlers to avoid memory leaks. Remember that. It's probably best to go back and listen to the entire lifecycle explanation a few times. It might surprise you how often it comes up. I've been asked about it many times. Interpolation is the double curly braces on each side of a value syntax, the data binding syntax shown here. And don't confuse this with TypeScript's string interpolation that is shown here with the $sign and the curly braces to format strings. They are very different things. Template statements are methods or properties that we can use in our templates or HTML to respond to user input. They are isolated to the component or directive they're attached to and that component or directive's context. In this first example with a text box, the template statement is the notify change designation. And the second example, update customer, is the template statement. Angular services are special classes that provide a way for you to separate Angular app data and functions that can be used across your application by multiple components. Typically, they're pretty narrowly defined and they fulfill a very specific purpose. They're used by components to complete tasks that are separate from the application view and application logic. Good examples for services are fetching or persisting data, or validating user input, and logging. Lastly, services must be marked with the injectable decorator, and they also have to be registered as a service or a provider. The key components are all things we've already discussed: templates, components, services, modules, and decorators and metadata. CLI is an acronym for Command Line Interface. The Angular CLI is really helpful when you're building your applications. It can be used for initializing, developing, scaffolding, and maintaining your applications from the command line. It removes the need for you to have to memorize the structure of components or services or modules. Instead, you just use the appropriate command and the CLI will generate skeleton objects for you. Here's a few that you're likely to run into. Add's a bit confusing. You might expect it to be the one that you call for generating those skeleton objects, but no. Add actually adds a dependency to an external library to your project. Build compiles your Angular application into an output directory. Deploy calls the deploy builder for the default project in your workspace. Generate is what you use to create components and services and modules. Most of the complicated ones have a multi-step process. So if you call ng generate component, it'll ask you for the important details like name before doing the generation. New creates a new Angular workspace. Serve builds and serves the application with hot reloading. So if your application views or components change and you save, the application will automatically reload. And test runs the unit tests in a project. Dependency injection is an easy way for your Angular components to gain access to the resources that they need. For example, if you need an HTTP client in your component, you would just add it to your component's constructor, and Angular can help with the delivery of that service to your component. I think we'll wrap up there. I have hundreds of Angular interview questions, but videos take time. Before leaving, do me a solid and subscribe. If you want to watch a pretty cool C# video, I put out this one that shows you how to build a blockchain in C#. It isn't as complicated as you think it is. Until next time, keep coding.